day, everyone. So our lesson for today is about free fall. When do we say that an object is freely falling? Okay, an object falls under the influence of gravity alone, that is free fall, and it's not affected by air resistance. If we are going to look at this illustration, so we have here, this one. For the pebble, it's freely falling. It's not affected by air resistance. But for this, it's greatly affected by air resistance. So this one is not a freely falling object. Okay, looking at the illustrations here, at 0 second, the velocity of the pebble was 0 meter per second. After 1 second, it's 9.8 meter per second. After 1 second, again, which makes it 2 seconds, it will become 19.6 meters per second. Then at time 3 seconds, it will become 29.4 meters per second. Then 39.2 meters per second. Then 49.0 meters per second. So you can see what happens to the velocity of the pebble as it falls. Okay, as time increases, the velocity also increases when the object is moving downward, because the gravitational force is also pulling it downward, so it becomes faster and faster. And also the increase in the velocity is always 9.8 meters per second. So it has an acceleration of 9.8 meters per second squared. So that means after 1 second, 9.8 meter per second is added to its velocity. So halimbawa yan, 49 minus 39.2, that is 9.8. 39.2 minus 29.4, that is also 9.8 meters per second. Okay? So free fall is also considered to be a uniformly accelerated motion. Dahil the acceleration is always constant, which is always 9.8. Take note also that when we throw an object upwards, so let's take a look at this illustration. Okay, take note also if we have here an object. Okay, we have mentioned that when the object falls under the influence of gravity, okay, it's moving with an acceleration equals negative g. Okay, so since it's accelerating, the negative sign tells us that it's downward, but it's still moving faster and faster as it goes down. But if you throw a pebble, or if you throw an object upwards, okay, what do you think will be the velocity at the top? So what goes up must come down. So here, at this final position, velocity becomes 0, and then it will go down again. Okay? The velocity here, it decreases because it's moving against gravitational force. That's why the velocity decreases until it reaches 0, and then it will fall back again. So then here, at an acceleration due to gravity, so it will be moving faster and faster at the final velocity Vf. If completely there's no air resistance, the initial velocity here is equal to the final velocity at this point, if there is no air resistance. Okay, now we are going to derive an equation for free fall. Okay, I already have mentioned that free fall is also considered to be a uniformly accelerated motion. So let's take a look at the equations for uniformly accelerated motion. Let's review. Okay, we have Vf equals Vi plus At, wherein Vf is the final velocity, Vi is the initial velocity, plus acceleration, then T is time. We also have Vf squared equals Vi squared plus 2Ad, wherein here, again, final velocity equals initial velocity squared plus 2 times the acceleration times the distance, as long as the initial distance, or our reference point, is x equals 0. Then we have another equation wherein we have the distance equals Vit plus 1/2 a t squared. So these are our uniformly accelerated motion equations. Now let's derive an equation for free fall based on this one. Okay, we have here, take note. So we have here, the acceleration A will become negative g, which is the acceleration due to gravity and downwards. So from the equation, we have here Vf equals Vi plus At. Change all A here, and A here also to negative g. So that's how we can derive an equation for free fall. So let's now have Vf equals Vi minus gt. And then we have here Vf squared equals Vi squared minus 2gd. And then we have here d equals Vit minus 1/2 gt squared. Okay? So these are our free fall equations. Change lang yung a into negative g. So whenever we substitute g, we will only substitute, whenever we have to substitute the acceleration due to gravity, we will only substitute 9.8 meter per second squared. We no longer have to add the negative because negative is already in our equations. Okay? So for you to be able to understand it better, I will show you the problem solving on free fall motion. Okay, when we also have an initial velocity which is equal to 0, for example, we drop an object from a certain height and then it has no initial velocity, our equation can become Vf. Okay, our equation can become Vf equals Vi minus gt. If the initial velocity is 0, so that will become Vf is just equal to negative gt. Another equation that we have equals d, or d equals Vit minus 1/2 gt squared. So this one is 0, so we can have distance is just equal to negative 1/2 gt squared if initial velocity is equal to 0. Okay, we also have Vf squared equals Vi squared minus 2gd. Since initial velocity will become 0 if the object is dropped, so we have Vf, or Vf squared is equal to negative 2gd. Okay? Okay, so let us solve example number 1. Randy drops an object from the top of a roof located at 19.6 meters above the ground. Okay, since the object is dropped, we have the initial velocity is equal to 0. And then the distance that it has to travel, it's 19.6. And then this is the 19.6. Okay, we have here the reference point. Since it started at this point, let's have y is equal to 0. So the distance downward is negative 19.6 meters. Okay. So let's now try to solve this one. We are looking for the time required for the object to reach the ground. So let's check which of the equations can we use. Can we use Vf equals Vi minus gt, or Vf squared equals Vi squared minus 2gd, or d equals Vit minus 1/2 gt squared. Okay, again, what we are looking for is the time required for the object to reach the ground. Can we use the first equation? We don't have the final velocity and then we don't have time, so we cannot use this. Here, we have the distance, but we don't have the final velocity yet. So again, we cannot use this. Let's take a look at the last one. Okay, we have here d equals VIT. Our initial velocity is 0, and then meron din tayong g, which is 9.8. Then we are looking for time t. So we can use this equation. Yung d equals VIT minus 1/2 GT squared. So let's solve. Okay, d equals VIT minus 1/2 GT squared. So this one is dropped. So we have initial velocity is equal to 0. We now have an equation for d equals negative 1/2 GT squared. But we are looking for the time needed. So let's derive an equation for time. We wanted to look for t. So let's multiply everything by 2 and divide it by g. Okay, 2 divided by g. So we can cancel this out 2. Then we can cancel g. So what we now have here is 2d over g equals t squared. But we wanted to look for t. Alright, let's continue with this. We have negative here. Negative 2d over g equals t squared. So we now have to get the square root of both sides. There. So you now have t is equal to square root of negative 2t over g. So t equals negative 2 times, since the distance given is downward, we have negative 19.6 divided by 9.8. So our final answer for t is equal to, our final answer for t equals 2 seconds. Okay, so that's the time needed for the pebble to reach the ground. Okay, so let's have the next problem. Roa is riding the condor at Enchanted Kingdom. If he falls, or if it freely falls, for 4.8 seconds, what will be his final velocity and how far will he fall? So we are looking for two unknowns here. The given are, we have the given time, which is 4.8 seconds. And then initial velocity, since it started from rest, so the initial velocity again is equal to 0. We are looking for the final velocity. And then we are also looking for how far will he fall. So we are looking for the distance covered. Okay. So given time and time, can we look for the distance? Our distance equation, recall that we have d equals VIT minus 1/2 GT squared. So we're given the time, then we also know g, then the initial velocity is 0, so we can solve for the distance using this equation. Our VI now is equal to 0. Distance equals negative 1/2. G is 9.8. Again, substitute the 9.8 without the negative sign anymore because it's already included in the equation. Times the time given is 4.8 squared. Okay. Let's now have the final answer would be, okay, that would be a negative 112.90 meters. Okay, why negative? Because the reference will be at this point. So, halimbawa, ito yung condor natin. Okay, that is y equals 0. So, pababa siya. It was measured from this. That's why it's negative. It's negative 112.90 meters. Okay? So, because this one is our y, or distance equals 0. Now the next question is, or the first question was, what will be his final velocity? We were able to answer muna the distance covered. So the final velocity, let's solve. Okay, for the final velocity, we have Vf equals Vi minus Gt. So initial velocity natin ay also equal to 0. And then Vf is just equal to negative Gt. The time given here is 4.8. So Vf equals negative 9.8 meter per second squared times the time is 4.8 seconds. Cancel ang second. So we now have the final velocity is negative 47.04. And our unit, since na-cancel yung isang second, we have meters per second. Okay. Okay, just to show the cancellation of units here, let's go back to the first one. We have here 9.8 is in meter per second squared. And then you have the second squared. Cancel ang second squared. That's why the final unit for the distance is in meters. Okay, next item. Okay, next one. A basketball player jumps vertically upward with a hang time of 2.5 seconds. What was his initial velocity when he jumped? So here is the problem. Parang yan, umakyat siya sa taas. Then bumaba. The hang time here, the total time is 2.5 seconds. If you're going to divide it, that will be the half hang time. So sa 2.5, okay, so sa 2.5 we have 1.25 pataas and then 1.25 pababa. Okay? The question is, what was his initial velocity when he jumped? So we are looking for Vi here. Okay? So whenever we have this problem, for us to be able to analyze it, let's divide the problem into two parts. One is upward and then the other is downward. Since we are looking for the initial velocity, then let's look for itong side, yung pataas, okay, the upward motion. So let's analyze that. We have here, Vi is unknown. What is the velocity on top? Okay, what goes up must come down. So the velocity on top here, the final velocity is equal to 0. Then the time, the half of the hang time is equal to 1.25 seconds. So which of those equations are we going to use? Since we are looking for the initial velocity, so let's check the first equation. Okay, let's check our first equation. We have Vf equals Vi minus Gt. So you have initial velocity, we're looking for that. You have G, and then you also have time. The final velocity on top here is equal to 0. So let's derive an equation. Vi now, I will transfer this negative Gt on the other side. So magpa-plus ako ng Gt on both sides. Okay, so this will become positive, and then this will just become Vi. So Vi now is just equal to G times time. The initial velocity is 9.8 meters per second squared multiplied by the time 1.25 seconds. Cancel ang isang second. So our initial velocity is 0.25 meters per second. So that is the initial velocity. Okay, take note, it's positive because it's upwards. Now, if you're going to look at the downward motion, since air resistance is neglected, so the final velocity is also expected to be 12.25 meters per second. Pero let's try to solve it para I can show you how it will be different kapag downward. Okay, so as I have mentioned, what if the question is now the final velocity? So let's take a look at this. This time, we are going to look at the downward motion. Okay, let's take a look at the downward motion here. So this time, the initial velocity equals 0, and then we are looking for the final velocity. Then the time is also half of the 2.5, so that is 1.25 seconds. So we can also use VF equals VI minus GT. But this time, ang hinahanap natin ay final velocity, and our VI is equal to 0. So VF is just equal to negative G times time. So that's negative 9.8 meters per second squared multiplied by 1.25 seconds. Cancel, cancel. So that will give us, that will also give us negative 12.25 meters per second. Okay, take note that it's negative because it is downward. Okay, so that's for the third sample problem in your modules. Okay, so let's solve the problem. A child throws a ball straight down off the balcony of an apartment building at a speed of 7.5 meters per second. Calculate the position and the velocity of the ball 2 seconds later and make same calculations if it is thrown straight upwards. So this time, if it's thrown straight downward, if velocity initial is negative 7.5 meters per second, since it's thrown straight downward, then the time given is 2 seconds. We are to look for the position and the velocity, so we can solve for the velocity. And we can also solve for the distance. Distance equals VIT minus 1/2 GT squared. So you're given initial velocity and also you're given time. So just substitute. We have negative 7.5 since it's downward. Times the time is 2 seconds. Minus 1/2 times 9.8 meters per second squared times 2 seconds squared. Okay, so let's solve. Okay, the distance covered is negative 34.6 meters. So the interpretation for this one, for example, this is your reference, wherein y here is equal to 0. So the ball has already traveled a distance of negative 34.6 meters from this initial position. It doesn't mean that the total distance or the total height is 34.6, but from this, it has already traveled 34.6 meters. Okay, next is to solve for the velocity. For the final velocity, we have VF equals VI minus GT. So initial velocity, you substitute, it's negative 7.5 meters per second minus 9.8 meters per second squared times the time given is 2 seconds. So cancel ang isang second. So the final unit for final velocity is meter per second. Final velocity is equal to negative 27.1 meters per second. So it has already traveled negative 34.6 meters downward, and then at final velocity at this point is equal to negative 27.1 meters per second. Okay, so now let's solve the second part. Make same calculations if the ball is thrown straight upwards. So in this situation, we have our initial velocity is equal to, since it's thrown straight upwards, so it's equal to 7.5, positive 7.5 meters per second, and then the time is still 2 seconds. So we are looking for the position and velocity after 2 seconds. So let's solve for final velocity. Vi minus gt. The initial velocity is 7.5. So we have there 7.5 meters per second minus 9.8 times the time is 2 seconds. So let's take a look at the final velocity. Okay, for final velocity, we have negative 12.1 meters per second. Okay, for our final velocity, we have 12.1 meters per second. Then we also have to look for the position or the distance after 2 seconds. So we also have distance plus VIT minus 1/2 GT squared. So our initial velocity is 7.5 times we have the time 2. Okay, 2 seconds minus 1/2 times 9.8 times the time given again is 2. Then you have to square it. So the distance traveled would be okay, we have here negative 4.6 meters. Okay, now let's just discuss the interpretation of our answers. Okay, for example, we have here as the initial position y equals 0. The ball was thrown straight upward and then it will fall. So after 2 seconds, it has already reached negative 4.6 meters from this point. Therefore, at 2 seconds, it's already moving downwards. And then the velocity is equivalent to negative 12.1 meters per second. Okay, so let's have the sign here again, that is negative. So those are our answers for part B. So you have here the velocity is negative 12.1 meters per second, since it's already moving downward, and it has reached a distance of negative 4.6 meters from the initial position y is equal to 0. Okay, the next problem is also a challenge problem, so let's have another one. Let's take a look at this problem. A stone is thrown vertically upward with a speed of 12 meters per second from the edge of a cliff 75 meters high. How much later does it reach the bottom of the cliff? And then what is its speed just before hitting the bottom? And then the last question is, what is the total distance traveled? So let me draw first the situation we have. Okay, we have a cliff. Okay, we have here the cliff. And okay, there. Yan. So, here is the bottom of the cliff. Okay, kunyari may tubig sa cliff natin. Natin ng water. The situation is here, the cliff has a height of 75 meters. So, at this point, hindi na siya same yung ground level. So, it was thrown upwards, there, with an initial velocity of 12 meters per second. So, that's positive 12 meters per second. The question here is, how much later does it reach? So, that is the total time. The time to move upward plus the time downwards. And then, what is the speed just before hitting the bottom? So, we are looking for the final velocity here. And then, what is the total distance traveled? Yung upward na distance at saka yung downward. Okay? So, let us solve for that. For us to be able to solve this problem, i-divide natin siya into two parts. So, we have first the upward motion and then later on the downward motion. So, let's solve first yung upward motion. We're in at this point, the initial velocity here is 12 meters per second. But the final velocity on top, since yun nga, what goes up must come down, so the final velocity there is equal to 0. Okay. So, let's solve for the distance, yung peak niya, or the highest point that the stone will reach. So, we can have Vf squared equals Vi squared minus 2gd. Okay? So, here, the final velocity is equal to 0. So, pwede ko na itong ilipat sa kabila. So, I will add plus 2gd here and then lipat ko sa kabila. It will become positive. I now have Vi squared equals 2gd. Okay, we are after the distance, so let's divide the equation by 2g. Yan. So here we can cancel out 2g, and then we have now a formula of distance. Yan yung the highest peak. Ito. We are looking for that distance. So distance is equal to Vi squared over 2g. So since we're given Vi and then we know g, we simply substitute and we will get the distance. So let's continue to solve. We have distance equals Vi squared is 12. Okay, we have, for the Vi, we have 12 meters per second. Then you square that. Divided by 2 times 9.8. Okay, ang distance natin will become 7.35. So we have a distance of 7.35 meters. So take note of that. We have here distance equals 7.35 meters. So ito yung 7.35. Okay? Now, we can also solve for the time para ma-reach na yung peak. Okay, which of those equations can we use? Okay, tignan nyo yung equations and which of those can we use? Okay, let's solve for the time para ma-reach na yung let's solve for the time para ma-reach na yung highest point or the time upwards. So, we have Vf equals Vi minus gt. Again, final velocity natin is equal to 0. So, i-transfer ko ulit yan on the other side. So, we have Vi equals gt. But we are after time, so let's divide both sides of the equation by g. So, ang time natin, upwards equals Vi over g. Okay? So, let's substitute. Our initial velocity is 12 meters per second divided by 9.8 meter per second squared. So, makancel yung meter, second, isang second. So, we'll have that unit for time is seconds. The time natin upwards equals we have 1.22 seconds. Okay? So, that will be our time, 1.22 seconds. Okay, note natin here, time upwards equals 1.22 seconds. Okay, next. Let's now analyze yung downward motion naman. Okay, so now let's solve for the downward motion. We can solve for the final velocity, and then we can also solve for the time. In solving for the final velocity, let's check. Okay, we have here Vf equals Vi minus Gt. So, can we use this equation? Di pa, because we don't have time yet. Okay, we also don't have final velocity. So, let's check the second equation. We have Vf squared equals Vi squared minus 2Gd. Okay, looking at this, we don't know the final velocity at this point, but we know the initial velocity. Kasi, since we are analyzing the downward motion, this time, our Vi is equal to 0. Pababa na siya. Nag-stop muna siya on top. So, that's the final velocity do sa upward motion. Pero when it comes to downward motion, that will be our initial velocity. Kaya ang Vi natin is equal to 0. So, Vi squared will become 0. Okay? So, we now have an equation wherein Vf squared equals negative 2Gd. And then, we can solve for Vf is equivalent to square root of negative or positive square root of negative 2Gd. Positive or negative. So, we now have final velocity is equal to the positive negative root of negative 2 times 9.8 times the distance. Since take note that the distance is pababa na siya, this will be our y equals 0. This is our y equals 0. So, yung distance na gagamitin natin now ay negative. The final velocity we have Vf equals positive negative square root of negative 2 times 9.8 times, since it's downward, it's negative. Your negative distance will be the 75 meters plus the 7.35. Total of 82.35. The final velocity is, okay, for the final velocity we have 40.18. So, 40.18 meters per second. Now, we are going to choose the negative one because it's already moving downward. Okay? So, syempre, ang calculator cannot tell us whether it's positive or negative, but upon analysis, since the stone is moving downwards, so it's more appropriate to use the negative sign, which is the final velocity is negative 40.18 meters per second. Hindi pa pala tayo tapos. So, we still have to solve for the time downwards so that we can answer yung question na total time. Okay? So we already have final velocity is equivalent to negative 40.18 meters per second. We can already use this equation since we already have final velocity. So final velocity is equal to VI minus GT. But take note here that our initial velocity dun sa downwards, the initial velocity is already 0. So we can get the time is equivalent to negative VF over G. So substituting our answer for the final velocity, we have here time. Time is equal to negative 40.18 meters per second divided by 9.8 meters per second squared. Okay? So we have 40.18 divided by 9.8. Okay, the time downwards, yan naman yung for the downward motion, we have here is equivalent to 4.1 seconds. Okay? So there, time downwards, let's note that. Ang time downwards naman natin ay 4.1 seconds. Okay, for us to be able to answer yung total time, yan, how much later does it reach the bottom? So that is the total time. We simply add the time upwards and then yung time downwards. So we have 1.22 seconds plus 4.1 seconds. So that will give us 5.32 seconds. So, yan na yung total time. Final velocity, we were able to answer that. And then yung next naman ay yung total distance. The total distance, since we are talking about the distance, not the displacement, so we have to indicate yung pataas at saka yung pababa. So, that will be 7.35 pataas. Then another 7.35. Then, of course, the height of the cliff, plus 75. So, that will be the total distance. And that is equal to 89.7 meters. So, the answer is 89.7 meters. Since we are looking for the total distance covered. Okay, so that's it. Finally, we were able to arrive at the answers. We have final velocity as negative 40.18 meters per second, the total time as 5.32 seconds, and then the total distance traveled will be 89.7 meters. Okay, so it's time for you to answer the exercises in the module. If you have questions, just leave your comments down below or leave your comments in our group. Bye! See you in the next lecture.